Hi guys, myself again. In this video, we shall see another problem on LeetCode. Next, permutation. So, a permutation of an array of integers is the arrangement of its members into a sequence or a linear order. So, basically, it's in nothing but in dictionary order. We are arranging the elements in the array. So, if the given array, let's say 1, 2, 3, 1, 2, and 3. So, the different possibilities are like 1, then 3, 2. So you could say 123 is lesser than 132. So next thing will be, so these two are interchanged. Next comes with 2. So with 2, 1 and 3, the next bigger number. So the next bigger number next to this is 2 is okay. So rearrange these two, reverse this. So 3, 1. Next start with 3. So in that 1, 2 and next comes with 3, 2, 1. So you could see all these elements are in dictionary order. That means they are in ascending order. So that is what we need. We have to, so if in the given question, if they say this is a given, if this is given, then we have to find the next permutation of this. That means we have to reorder the elements of the array into this format. So that is the question to be solved. What if the given question itself is containing 3 to 1? Then what we do? So in such case, we need to print the very first permutation, that is 1 to 3. That means if it is the last permutation. Yeah, sorry. So if it is the last permutation is present as a given question, then you need to print out the very first thing only. That means it's a sorting the array 1, 2, 3, or reversing the array. Anything is fine. So this is what we need to do in the problem. So let's analyze the problem with a bigger example. You could see 2789410, right? So all these are given. Now how do we start with the problem? So let's first check. Let's first take this entire portion except the last element and check whether we can rearrange this last element 0. Can you rearrange this anything? That remains the same number. Okay, next we will leave the last two elements. So only 1 to till 4 we will take, and can we rearrange 1 0? It will be nothing but 0 1. But if you observe 0 1 is of course lesser than 1 0, right? 10 is lesser than 10 is greater than 1. So if you see, the number will be 2 7 8 9 4 0 1. This will be lesser than 1 0. So that is not the case. So will not this take into consideration of this also. Next again leave one more element till 9 we will take. Now 410 we have. So what are the other possible combination or permutations of this 410? We can take it as a 401 or 104 or 014. But if you observe all these numbers, they are lesser than 410, the given number, right? So if you see the observation in this, the next number after this fixed number what we have taken, the next number to it, we have to check whether there any number greater than 4. No, 1 is not greater than 4, 0 is not greater than 4. If in case instead of 1 we had 5 over here, then what it will happen? So then we will have a combination of 540 which is greater than 450, which is greater than this combination 450. So the next greater permutation to this number will be 278949540 will be the next permutation. So that is what we are looking for. Okay, now this is not possible. 410 is not possible. Now we will remove, exclude one more element 9. So 9410 we have. So as I said before, we have to check, is there any element greater than 9? Can there be an element greater than 9? Of course it is done, but with a single digit it's not possible. In the single digit, 9 is the greatest element. So any possible combination, 9104 or 9014 or 4901, all these numbers will be lesser than 9401, 9410, sorry. So that is for sure. So we cannot take this also. So next element we will move on. So we'll exclude 8 and we'll take 2 and 7 only. So now if you observe, for this 8, is there any greater element present in the remaining array? Yes, 9 is a greater element present. So there can be a combination starting with, instead of 8, if we take 9 and any number after that, it will be greater than 89410, because instead of 89410, if I take 98410, that is greater than this. If I take 94810, that is also greater than this. If I take 90148, even that is also greater than this. So any number starting from 9 is greater than this number 89410. So how do we get to know now? Now in the permutation, one thing we got to know, observation, that till here if you observe carefully, 0 is less than 1, 1 is less than 4, 4 is less than 9, 9 is not less than 8. So at this point the break comes. The break comes at this point. Till here it went on increasing, then it went on decreasing, right? Then again, yeah, it went on decreasing. So, but this is the point at which we need to change the permutation. So, once you get a number lesser than its next number, we have to exchange the element. So, this is the break point. So, we have to exchange the number with the 9 now. So, before exchanging, let's tell the first step is to check to get this breakpoint. So we will have a pointer called index. I will start comparing whether this element is greater than this element. No. This element greater than this element. No. This F4 is greater than 9. I mean, I am telling in the reverse way. Sorry. So 0 is lesser than 1. Okay. 1 is lesser than 4. Okay. 4 is lesser than 9. Okay. But 9 is not lesser than 8. So in this case, index will be equal to this 8. So it will be nothing but, let's say, I. Okay. So index will be pointing to it. So we run the for loop and keep on checking that when I write the program, we'll get to know. That is the first step. So we'll have a pointer called index over here now. So once you get the index, now we have to exchange this 8 with the next greater element presenting in the remaining array. So here it's 9, but it cannot be the next element itself. So if in case I'll take some other example, let's say 1, 5, then 9, 7, 3, 2. So if you observe here, same case, 2 is lesser than 3, 3 is lesser than 7, 7 is lesser than 9, but 9 is not lesser than 5. So this is the thing, right? So here is the breakpoint comes here. Now 5 should be exchanged with the next greater element. That is nothing but 7 in the remaining array. So 5 should be exchanged with next greater element 7, not 9. But here there were no other elements such in such case. So we exchange it with 9 itself. We have to exchange it with 9. But usually again we have to traverse back from the array and start looking for the element that is greater than 5. Is 2 greater than 5? No. 3 greater than 5? No. 7 greater than 5? Yes. Then exchange this two. So that will give the array as 1, 7, 9, 5, 3, 2. So we have the index pointing here now. So now what you need to do? Now, as I said before, among this, all the possible combinations we have. So here also, if you take 9532, it can be the next greater element which starts with 7. So after 7, it can be 73592 or 72359. Any different numbers are possible. Similarly here also, as I said, 98410, 94810. But how do we get to know the next greater element is this one in the dictionary format? So for that it's very simple. So you have 8, you exchange it with 9. So I'll just exchange this. So this is 9 and here it will be 8. So if you basically do the sorting of this or reversing of this array elements, it will give you 0, 1, 4, 8. That will be the next greater element to the this permutation, because 2, 7, 9, 0, 1, 4, 8. Correct? If I take in case 4810, it is greater than 0148. So any number. So after 9, so once you get the indexing, the point at which the decrement is happening, the next element should be greater than the previous element. So once you exchange those two, then the remaining elements of the array, either you can sort them or reverse them also, because they are in the decreasing order. They will be in the decreasing order. Why? That we are looking for the point at which this inclination is happening. Once it goes increasing, then decreasing. So if here only there was an inclination, then we would have taken the next permutation here itself, right? So that is why at first you find an index, then you do the next greater element. So once you found the index, you exchange with the next greater element, then you sort the remaining array. So this is what the algorithm. So first we will have int n equal to nums.length. Next we'll have a indexing. Let's point it to -1. And one more thing, yeah, one more thing. So as I said, in case of 1 to 3, the last permutation was 3 to 1, right? So if the given question contains the last permutation only, then what? It will be in the decreasing order. The element will be in the decreasing order. So in such case, this first loop will not get any index only, because 1 is lesser than 2, 2 is lesser than 3. Will not get any indexing where one element is greater than the previous element. That means something like this: 1, 3, 2. So here 1 is lesser than 3, but 3 is not lesser than 2. So here indexing happens. But here 1 is lesser than 2, 2 is lesser than 3. So in such case, after the loop also, if indexing equal to -1, then just sort the array or reverse the array. That will work. So for int I will be starting from last position and I greater than 0. So why I greater than 0? I'll just explain that once. So as I said, here in the array 279, 278, 9410. Why greater than 0 we give? Because we compare this with previous element, previous element, previous element, previous element. So if we take till 0th position, there is no other element over here. So till here only we traverse the loop. So that's why I'll write for int I equal to n minus 1, then I should be greater than 0, I minus minus. Now check if nums of I, if it is greater than nums of I minus 1. So here you can see 9 will be greater than 8. Nums of I is greater than nums of I minus 1. So index 7 will point to this position. So I minus 1. So this is I minus 1. So index will be equal to I minus 1. So index will be equal to I minus 1. And then break. Okay, if condition becomes true only, you have to break it, right? So inside the if condition, you have to give the condition break. So after the for loop, as I said before, what if the last permutation is present? So check if index is still equal to -1. Then what we need to do? Arrays dot sort of the entire array. So after this, after you find the indexing, next step will be swapping the next greater limit. So you have, in such case, you have to traverse the array from the last position till the index plus 1 position. So again, for I equal to n minus 1, I greater than index I plus plus, sorry, I minus minus. Check if anywhere nums of I is greater than nums of index. Then what we need to do, if nums of I is greater than nums of index, swap those two elements. So we'll create a temporary variable in that will store nums of I. Now we can change nums of I will be equal to nums of index. So after you assign it, now you can change nums of index will be equal to temp. So what basically we did is, so we create a temporary variable in that, so 0, 1, 2, 3. So 1 and 3 position. So nums of 1 we store, that is 5. So since 5 is stored in temp, now you can change the nums of 1 equal to 7. So nums of 1 will be equal to nums of 3. So that is nothing but 7. So now this get replaced by 7. Now you can replace 7 by the value at this position that is stored in temp. So nums of 3 will be equal to temp. So that is nothing but 5. So this is what we did over here. So after the reversing is done, now we have to sort this or reverse this remaining array. So for reversing the remaining array or sorting the remaining array, I'll give arrays dot sort only. Arrays dot sort of array nums starting from index plus 1 position till n. So why am I giving n? We need from index plus 1 position till n minus 1. But this last number will be excluded. So till n minus 1, index plus 1 to n minus 1 position, it will sort. And hence the return type is void. You can just directly submit the code. Okay. So here also, if condition becomes true, you have to give a break statement, because after that you need not to do exchange anything. So that's why it was showing the error of this. Okay, why is it so? Yeah. So if indexing equal to minus, then once you sort the array, you need to return. No more execution of this code is required, because if index equal to minus 1, how will it traverse? Terms of minus 1 is not present only. So that's why the problem occurred. Yeah. So for C++ also, same thing only. So I'll just traverse to the code once. So size, you break, find the index, then sort of here we have to mention the range. So begin till the end we give. Then again swap the numbers. Since we have the swap function, directly we can use that. Then again nums dot begin plus index plus 1. So index plus 1 till the end it will sort. So we'll submit this also. Yeah, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with other next session. Until then, keep learning. Thank you.